Today we're going to be talking about architectural detailing and ensuring that you've got some of the tools so that you can review a detail, you can understand what should be working at and what shouldn't be working at. There are three really critical things that you need to understand. So we're going to run through them one by one so that you understand what they are, how to look out for them, and ensure that you've got them in your building design. Okay, so here is the detail that we're going to break down, and I want to try and simplify this into its specific layers in regard to what makes it a high performance detail and why it works. And that way, hopefully you can apply that same level of thinking to actually scrutinize other details and make sure that they are performing in the way that they should, and also be able to identify where the gaps in that performance are. So the first thing we're going to do on this is have a look at where the air tightness is achieved in this detail. So I'm going to draw the air tightness layer here with a green pen, and just so we can do it as an overlay. First thing to understand is that on our floor, where we've got a concrete floor, concrete is largely considered to be an airtight material. Now, it doesn't always be that case. You may get some cracks through it, you may have some services and so on coming through it, but they can generally be dealt with an epoxy or some sort of sealing around those services itself. For the case of this detail, we're going to consider the concrete to be airtight. So that is the wall considered as airtight. Now the next part is it's floor. The next part is the wall. So in this one, we've got a structural insulated panel that sits through here. And the inside layer of the structural insulated panel has got what's called an OSB board. So it's oscillated strand board. And that board in itself has got a very good layer degree of air tightness in it. Now, the joints between the panels themselves will also need to be dealt with. So what we do with that is we have a specialist airtight tape that creates a really good seal onto the OSB board, connecting one panel to the next. And it's a very simple solution. So we don't need to create a full membrane on the inside of any building that's created with structural insulated panels. You just need to deal with the joints themselves. And the last thing in this is we need to ensure that the connection between the floor and the wall is actually taped as well. So we actually put some tape in this junction. And whenever we do that, we've now got a nice seamless airtight joint between those two structures. And so that is the air tightness taken care of. The next part on this is the insulated construction itself and how we actually create the thermal side of this detail, making sure that it's kept nice and keeps you nice and controlled with temperature internally. So you can see the structural insulated panel itself has this beautiful big fat piece of insulation through the middle of it. And this is why structural insulated panels are so good, is because this insulation coming the whole way through and the full length of this panel has no structure in it at all. It's pure insulation, and so it's uninterrupted and it's performing really well across that whole width and maximizing the performance of that wall. Now, at the bottom of any insulated panel, you will have a timber stud, which is used to connect them together. And whenever it comes to the ground, we've actually got two studs that we need to place onto the ground themselves. The first one is isolated from the slab itself with a damp-proof course. And then we've got another one, which is a receiver that we place on the top. And then the structural insulated panel slides down over the top. And this has got a male-female connection between the OSB on either side and the stud, which is at the end of the insulated panel. These three pieces of timber will not perform quite as well as the insulation itself. So this is sort of slightly down on the performance of this, but it's still performing quite well. Timber does perform quite well thermally. But what we want to do is just give this a little bit of a boost as well and help it. So on the inside of this wall, we have a service cavity which runs through here. And this is where we'll put our light switches and plugs and maybe some small plumbing fixtures and so on. And with between all of those, we'll also add insulation into this space as well. And that sort of wraps down through here, which keeps this edge nice and warm and taken care of. So that whole wall is nicely insulated looking at that. Now the next part is connecting that and making sure that the slab itself is actually kept warm. And so we've got our slab. We've created a set down here to receive the brick veneer. And what we want to do with that is where we've got our cavity tray, which is running our water out through the building, and then we've got a weep hole in our brick facade through here, which is allowing the water out and some air to get into this cavity. That is really creating a part where we've got a space below it here in this cavity, and we can insulate this zone as well. And if we insulate this one, it means that we're keeping this portion of the slab here disconnected from the outside air, and it keeps it warmer. It keeps it closer to what the inside temperature is. Now the rest of the slab we've got to then decouple from the ground. So the ground is largely a more consistent temperature than the outside air itself, but where it gets closer to the surface of the ground through here, for instance, you will get some degree of variance in the temperature as it gets to the slab edge in particular. And so what we want to do is just make sure that we wrap this insulation the whole way around this slab so that it decouples it from the ground itself, so that the slab is actually at the same temperature as our inside air, not the outside air. So we can control that and make sure that it isn't varying in that temperature. So we've got usually a 50 mil XPS insulation, which just wraps around all sides of that slab. And you'll need your engineer just to review that and make sure that the structural slab will still work within that, and structurally the insulation isn't creating an issue, but this has usually got very good structural capacity in itself. So that's two of our layers. So we've got the air tightness layer, and we've got the insulation layer taken care of in this detail. So the third layer that we need to consider here is then the weather resistance and how we actually stop the outside rainwater and wind and so on getting into the building itself. So the structural insulated panel itself can do a good job, but it's got an OSB on the outside, which is a timber surface, and we want to protect that, and we want to ensure that we don't get any water penetration through that. So what we need to do is apply a membrane which runs down the face of the OSB board and continues the whole way down the slab edge. And then we've got a membrane underneath the slab itself. Before we put our insulation, or just after we put the insulation on, we put a membrane on top of that as well, which is a damp-proof membrane, and that stops any water egress coming up from the ground, coming in and saturating the slab in any way, and we're protecting it. And we're going to wrap that right up and around and into here. And again, we're just going to do some taping of the wall membrane to the floor membrane at this point, so that it's got a really nice continuous line the whole way through. Okay, so if we look at these three layers, you can see the red one I've just drawn here is nice and continuous the whole way through. This is our our weather protection, or weather resistant barrier, WRB, we often refer to it. So nice and consistent, runs the whole way through, isolating the inside from the outside. And then we've got our insulation. So again, just in simple terms, we're considering the timber as being insulative as well. So that is insulated. We've then got the bit down that edge, and we've got it through here as well. So this is largely a continuous layer, and we've got some more on the inside through here. So this is largely a continuous layer. Now there is one gap in it, and that is at the top of the slab at this point here. And so there is a question about whether we could do something to make sure that we increase the capacity here. Now, one thing that we could do is we could build that brick on another piece of XPS in that position there. Whether that will create a stable enough base, I'm not sure whether that might work, but that could be something we're doing. But in general, this small thermal bridge at this point, which is called the gap in this insulation, isn't too much of a concern because it's quite far away from the internal space. And if this is nice and warm through here, it takes quite a lot for that heat to pass through that concrete slab to escape through here, and vice versa. It takes quite a lot for that external temperature to actually control this slab and make a big difference in the variance on the inside. So not too bad, this detail from that point of view, although not perfect. And then the third layer on the inside is the air tightness layer, which is this green line. So again, really nice and continuous through here. So there you have it. There's the three layers that we are talking about. The green layer is air tightness. The yellow layer is the thermal barrier, and the red one is the weather resistance barrier. And all three of them are working quite well in this detail, although there are some improvements potentially that could be made. There you have it. That is a review, very high level review of the three critical layers in any sort of high performance details. Just make sure that anytime that you see an architectural detail, no matter what the scale is, whether it's a section, a plan detail, you should always be able to find these three particular layers. Get three different colored pens out, see if you can draw them in, see if you can actually connect all the lines up and ensure that you've got them continuous. Any gaps in those lines will mean that you've got a potential failure within the high performance envelope of your building, and it may result in your health, your performance, and the resilience of the building not being as good as it possibly could be. Until next time, I'm Roger Borland. Thank you.